we should learn. So a sequence is an ordered list of numbers. So an arithmetic sequence is a sequence of numbers that follows a pattern of adding a fixed number, otherwise known as a common difference, from one term to the next, and the common difference is represented by the letter D. And the equation is a to the a sub n equals a sub 1 plus d n minus 1 times n minus 1. So here's an example. So find the 59th term of this arithmetic sequence, 5, 8, 11, 14, yada, yada, yada. So you have the fixed number is plus 3, obviously. And you have your a sub 1 as 5. So you do 5 plus 3, and then n minus 1, and your n is 59. So 59 minus 1 is 58. And you do this to get the 59th term. And then the sum up term is represented as S sub n equals a1, a2 plus a3, yada, yada, yada again. The sigma notation is sigma and n k equals 1. K equals 1, and then parentheses a to the first plus t a minus 1. And then it gets out to equal 0.5n times 2a1 plus d times n minus 1, or 0.5n a sub 1 plus a sub n. So let's find the sum of this one. So what you do is we have a plus 11 plus 14 plus 3n plus 5. So the sigma notation is sigma and k equals 1, 3k plus 5, and you have a sub 1 equals 8. So you get n over 2 equals 8 plus, when you plug in 3n minus 5 plus 5. And you get n over 2, 3n plus 13. And that's how you solve it. You can use either one for sigma notation. It is your preference. And that's it for arithmetic sequences.
So what is the sum of that? Can you do the final calculation for us?
Well, because you don't know what n is.
Oh,
so we have an
oh, so we could take, okay, okay.
Okay, so for geometric sequences, each term is found by multiplying the previous term by a constant. And the first term is represented by a, and then the constant, which is called the common ratio, is represented by r. So this is the equation that you use to find the numbers. So for example, if a equals 3 over 16, then if you use this equation, you can find what is a sub 4. So how you would do that is, you know that a equals 3 over 16, and then this number is r. So r equals -2, and then so you just plug in n is 4. So you do a sub 4 equals -2 times 3 over 16 to the third, because n minus 1 is 4 minus 1, so it's to the third. So you get a sub 4 equals -2 times, I'm sorry, this is written backwards. It should be 3 over 16 times -2 to the third. So it should be 3 over 16 times -8 equals -3 over 2. So that's how you would basically find, like you would solve that. So then to find the sum of an infinite geometric sequence, if r is greater than or equal to 1, you can't find the sum, because the sum is just going to be infinity, because it's going to be steadily increasing. It's just going to like keep on going up. But if r, or the absolute value of r is less than 1, then you can find the sequence, and this is the equation that you use. So for example, in this equation, you know that A equals 1/2, and R also equals 1/2. Do we have better markers? A equals 1/2, and R equals 1/2. So basically you just plug that into the equation. So the sum equals 1/2 over 1 minus R, which is 1 minus 1/2, so 1/2 over 1/2, the sum equals 1.
How much time do we have left?
You have about 1 minute.
Okay, so we're gonna try this word problem. So Sally is bungee jumping. On the initial jump, the cord stretches 120 feet. On the next bounce, the stretch is 60% of the original jump, and each additional jump stretches the rope 60% of the previous stretch. What is the stretch of the rope on the third jump? So you know that A equals 120 and R equals 60%, which is 0.6. So you just plug in A sub n equals, well, n equals 3 because you're doing the third jump. So A sub 3 equals 120 times 0.6 times n minus 1, and since n is 3, n minus 1 equals 2. So if you evaluate that, you should find 43.2 feet for the third jump.
Now, the difference between arithmetic and geometric sequences is an arithmetic sequence requires a constant to be added or subtracted, while a geometric sequence requires a constant to be multiplied. And a geometric sequence will increase more rapidly than an arithmetic, and an arithmetic sequence will increase more gradually than a geometric sequence.
Okay, we'll stop you there and ask for questions.
It's pretty straightforward.
No questions.
Sophie.
Are there any real life applications that would be practical? Like, I don't know, if you don't need to calculate the length of some toes.
Well, I didn't like see any other ones. I mean, I didn't look for specific other ones, but I mean, if there's anything where it's like bouncing back for anything that's not like bungee jumping, that could also be a sequence. Yeah.
Is there an opposite phase where you subtract or divide or something?
Yeah, well, I mean, you can, for arithmetic sequence, you can also subtract, and then for a geometric sequence, you can multiply by a fraction, which would be simple.
Yeah.
Okay, well, we'll stop there. Thank you, Phil. That was great. Okay, so you guys.